Hello everyone. Let's talk about file exceptions. Let me give you example scenarios where you might encounter exception while processing files. Let's say that you want to open a file and read its contents. Suppose such a file doesn't even exist, or if you don't have sufficient permission to open and read the content of a file, then you're going to run into exception with both of those scenarios. We've already spoken about the insufficient hard disk space problem during the beginning of the lecture. Let's say that your hard disk is nearly full and that you want to create a brand new file and write contents to it. So you're going to run into an exception in that scenario. You might also encounter exceptions if you mix up directories and files. Another scenario where you might run into an exception is when you have corrupt file formats. Let me give you an example here. Let's say that somebody has tried to create a JSON format file, but they somehow mess up the format and have some issues with the actual JSON's format, content format. Let's say that I am writing a program which wants to open that JSON file and parse its content into an appropriate data structure inside Python. We are going to run into an exception because the person who created the original JSON format file did not do it incorrectly. Let's go through a concrete example over here. So I have a snippet of code down here, and the objective of this snippet of code is going to be to create a directory called dump and then to create a file called out.txt inside dump and add the string hi inside that file. Let's first step through this example. Recall that you need to import the OS module to use the mkdir function. We just covered what mkdir function does. It enables you to create the dump directory which you pass as argument in the current working directory. What are we doing then? Notice that we are using os.path.join function call, which is really important, and you should always use that rather than hard coding your slashes, because your code will become not portable if you hard code your slashes. So we want to join dump and out.txt with appropriate forward or backward slash depending on what OS we currently run this program on. What is the join function called return? It returns a string, correct? So that string is going to give us the relative path to out.txt over here. Recall that your first argument to the open function call should be a string which contains the relative path to the file. What are we passing as second argument here? We are passing w for the write mode, and we are going to get a file object out of the open function call. We are going to use the write function call to write the string hi into the file object f, and we close the file handle for the file object f without forgetting. Let's suppose we are running this script for the first time and assume that there is no dump directory previously available in the current working directory. Then you'll go ahead and create the dump directory, and if you have a brand new dump directory, then you're going to create a brand new out.txt file and you're going to add the content hi into that file. What would happen if we run this program a second time? It would cause the program to throw an exception. It will throw an exception called file exists error, and the exception is going to occur in line number 3. That's because you cannot call the mkdir function to create a specific directory which already exists. So this exception naming is a little bad. It says file exists error even though we are dealing with a directory here, but it still refers to the fact that the directory exists. Let's talk about how we can deal with this particular exception. Recall that we used to write try except block around the snippet of code which might possibly throw an exception, correct? So I'm going to do the same here. I'm going to add the os.mkdir function call inside a try block. And in the except block, I don't want to catch everything, so I'm not going to say except colon. Instead, I'm going to say except file exists error colon. If you want to get the string associated with that particular exception object instance, you will say except file exists error as E. I'm not going to say the as E because I'm not going to use the string value associated with that particular exception object instance. So let's talk about the two different scenarios here. Scenario number one is when the dump directory doesn't exist. What will your script do then? It will go ahead and run your try block. It will go ahead and create the dump directory, and since you did not run into any exception inside your try block, you're never going to run your exit block, so you're good because the rest of the program will create out.txt for you. Scenario number two is when your dump directory already exists. You'll run the try block. This mkdir function call will throw the file exists error exception. We are catching that exception in the except block. So what do we want to do after that? Pretty much nothing, right? You wanted to create a file called out.txt inside the directory dump. It's already created, so you don't have to create the directory and you can directly create the file. So that's why we just have the pass keyword inside the except block over here. Why did we not use the as E along with the exception name? That's because I don't really want to do anything with that exception object. Let's talk about the next topic, which is going to be a tricky topic called as encoding. Human beings like to process and deal with strings and alphabets all the time. Computers, on the other hand, always deal with zeros and ones. So which means that all of your files are going to be stored as 0 and 1 representation inside your hard disk, correct? But then when you open the file and process it, you're still getting alphabets and string values out of this. So the process which takes any string format which is human readable and converts it into 0 and 1 binary format which is readable by a computer is called as encoding. The opposite process is called decoding, where you take the binary representation using 0-1 format and convert that representation back into the human readable format which contains alphabets and strings. We are going to go through a fun exercise now. Unfortunately, this exercise would have been so much fun if you can do it with a partner. So instead of that, I'm going to assign both the role of an encoder to you and the role of a decoder to you. Notice that I have a word up on the top right corner here which says ukulele, UKULELE. We are going to use encoding 1 to apply encoding to this particular string over here. Then for fun, we are going to apply encoding 2 in order to decode the 0-1 representation, which is the encoded representation of the string ukulele. Go ahead and pause the lecture video here and use the encoding in order to perform the encoding process and the decoding process. Feel free to just convert the letters into upper cases because you can assume that the encoding for upper cases and lower cases are going to be same just for this example's sake. What did you get when you applied encoding 1 for encoding the string and applied encoding 2 for decoding the string? You would have gotten this output where U got converted to L and K got converted to O and U again got converted to L. And notice that you didn't have any representation at all for L in the second encoding over here. So what you're going to get is something like lol double E here, where 2 of your original characters completely went missing. So this is what happens when you use a different encoding for the encoding process and a different kind of encoding for the decoding process. A lot of operating systems have their own specific encoding for encoding the file format. So most of your files only have strings which contain alphabets. So you're going to take that particular format and create some form of encoded format so that the computer can store it and retrieve it when you're processing that particular file. So the most common encoding format that you'll encounter is going to be the UTF-8 format. Unfortunately, that's a standard format only for Mac and Linux operating systems. Windows operating systems has a number of encoding formats and they keep changing it over and over again. Even they have inconsistencies between their own different encoding formats that they have come up with. Let me go through an example over here. Let's say that I'm creating a file called example.txt on a Mac. I am going to add one more parameter to my open function called description over here. That's going to be the encoding parameter. We have used this parameter while dealing with CSV files and JSON files. The argument to the parameter is going to be the UTF-8 string, which represents the UTF-8 encoding. Let's say that I want to write the string called banyo. Notice that we have an INEA here. This is totally allowed. You should be able to create example.txt which contains the string banyo. What would happen if you take the example.txt and move it into a Windows operating system and try to open the file on the Windows operating system using a different encoding, which is CP1252, one of the examples of the Windows-based encodings over here. Instead of reading the string banyo, you're now going to read a weird string which has like ba plus or minus o, something like that. So you see what happened, right? This is the problem with respect to using different encoding while writing a file and different encoding while trying to read a file. Notice the different function call usage here. I use the write function call in the code snippet on the Mac, and I use the read function call in the code snippet when I'm trying to read the file on Windows. So this is something that you should always try to avoid. Whenever you see a bunch of gibberish characters appearing with respect to file processing, it is highly likely that you're using an improper encoding format to read the particular file when the file was originally written with a different encoding format. All right, I'll wrap up the video here. In the next video, we'll do a short demo for file processing.